Let's get ready to do some math. How we doing, pre-calculus honors? I believe it's Wednesday, and Wednesday is a good day. Not too long of a lesson today. Tomorrow as well. We're kind of finishing up this topic right here. Here is number 20 for the homework. 100 things cut off over here by hole punchers and all kinds of stuff like that. Hopefully it wasn't too terrible. Number 20, okay, with Calc Assist right here. Cool AP problem. Piece of an AP problem. We had region R over here. We had region S over here. They wanted you to find the area of R, the area of S. Shouldn't have been too terrible. Okay, use that calculator to get this intersection value right here. You probably use the calculator over here only to realize it was 1. You could let C equal 1 and then use C if you want to, because some people already have, set up let's C equals. Really up to you. So hopefully this is okay. If not, join one of my Google Meet extra help sessions, or even better, send me a reminder, an email with a picture. Usually you do things quicker that way. Anyway, 23, that for homework with no calculator. Let's do it together, okay? Let R be the region in the first quadrant. It's always important, right? Bounded by the graphs of y equals radical x and y equals x over 3, which is really y equals 1/3 x. If they want the area of region R, it'd be useful if you could actually draw out what region R looks like. You should easily be able to graph y equals radical x. Some people are like, how do I graph y equals 1/3 x? Well, it's just a linear with a y-intercept of 0 and a slope of 1/3. Okay, so we know it's going to start at the origin, right? Because I have a y-intercept of 0. It's going to increase with the slope of 1/3. Okay, do the best you can. Doesn't need to be perfect. Okay, but here we have y equals x over 3. And you can see we now want the area of the region in between them, and that's our area between two curves. Okay, so I can set up my little rectangle, and we can see throughout the entire region, the upper curve is going to be radical x. The lower curve is going to be x over 3. So area is equal to integral. We know the upper function is radical x minus lower function, which is x over 3. All with respect to x. You could do that without actually graphing it. You need to get the bounds first anyway. We need to get the bounds now. You're probably good enough to realize the lower bound is 0. The upper bound, not the easiest thing. You could even just play around, right? If you plug 9 into radical x, you get 3. If you plug 9 into x over 3, you get 3. So I know the upper bound is 3. Most people wouldn't do it that way. They'd set them equal if you want to know where two functions intersect. So here, take radical x, set it equal to x over 3. To get rid of that radical, I'd square both sides. Okay, and we'd have x is equal to, what is it, x squared over 9. I don't know, cross multiply here and get that x squared is equal to 9x. Don't divide by x on both sides. Never divide by a variable if that variable can equal 0, and certainly can equal 0 here. You'll end up dividing out a root. I'll subtract the 9x from both sides, factor out an x, and we can see that we get x equals 0 and x equals 9. Now what you could do is actually pick a number in between those two to plug back in to see which is upper, which is lower. I'd pick a 4 because it's a perfect square. If you plug a 4 into radical x, you get back a 2. If you plug a 4 into x over 3, you get back 4 over 3. What's 4 over 3? 1.3 repeating, which is going to be less than 2. So that's how you know he's the lower and this guy's the upper. Kind of silly for simple functions like this, but for more difficult functions, that could actually be useful. I said, by the way, the integral from 0 to 3. So why did I put 3 there and put 3 here? We know it's 9, and I said it was 9. So the reason I probably put a 3 there is that when you do actually plug the 9 in, you get back a y value of 3 for both. So you see how easily you can make a silly mistake or something like that. I don't mind making mistakes when teaching, because mistakes lead to knowledge and understanding, okay? There's nothing wrong with actually making a mistake. I miss steak as well. It's one of my favorite foods. I don't miss it. I've been eating it. So anyway, let's actually integrate. So what do we got? I don't know. Maybe you want to write it this way, right? The integral from 0 to 9 of x to the 1/2 minus 1/3 x. Because this is basic integration, okay? Functions whose arguments are just one single x over here. X to the, let's add 1 to the exponent, 3/2. Work over there, divide by 3/2. Rest of us multiply by 2/3. Minus, just pull the 1/3 to the side. Integrate x to the first, which is x squared over 2. And evaluate all of it from 0 to 9. And right now, if you're like, geez, that's really fast. What's going on? You got to practice your integration, man. I'm telling you, you got to be good at it. Real good. Just as good as you are at derivatives. I don't know, does it need to be cleaned up at all? It's 2/3 x to the 3/2 minus, what is that, 1/6 x squared? I could already tell plugging in here is going to be extremely annoying. let's dive right in, okay? You don't need to actually show the plugging in. Just be careful. The zero's sweet, though, right? If you plug in the 9 to the 3 halves is the square root of 9, which is 3. Let's cube that 3, get a 27. So 2/3 times 27, I'll write it up that way. Minus, if we plug the 9 in here, 9 squared is 81. 1/6 times 81. So that's pretty frothy without a calculator. But it's great, right? Because 0, you just get a 0 back when you actually plug in. So that's slightly cut off right there. But it doesn't matter because it's a 0. So I know what we do here. Divide by 3 top and bottom. We actually get 18 minus 81/6. And I guess the best thing we could do here is get a common denominator of 6. 6 times 18 is not difficult. 18 is 10 plus 8. So 6 times 18 is 10 times 6 plus, 8 times 6. So is that 60 plus 48? So 108 over 6 minus 81 over 6. So 108 minus 81 was that 19 plus 8. So is that 27/6? Okay, would be a fine answer. Divide by 3, top and bottom, and you could also have 9 halves. Okay, so that would be what you'd be seeing in multiple choice. Multiple parts of this problem here. First off, can you graph it? Second off, can you set up the integral? Okay, third off, can you integrate? And fourth off, can you perform basic math? Which, by the way, is my weakest part of all these problems over here. But really, it's not the worst thing in the world. If you practice it, you'll get better at this. Especially if you're not good at mental math, just keep practicing. Force yourself to do it. I know you're staring at this. You're like, oh, I want to do this, and then go play like a video game. No. Okay, please try the mental math. It's annoying. You're going to have a summer assignment assigned the last week of June. The week of June 22nd. I think that's last week of June. It's supposed to be like an Elwood Light week. I'm not supposed to do instruction with you guys, but I can assign stuff that you're going to see over the summer. So I'm going to give you the summer assignment that week. A lot of it is stuff like this, just without a calculator, evaluating stuff like that, graphing stuff without a calculator, because I want to make sure you have those fundamentals before next year. There's no calculus on the summer assignment because technically we start over next year, but all this stuff is going to be in your brain. A couple more. Definite integrals besides area between a function and the x-axis, besides area between two curves. You will see just definite integrals on your quest. See, you can put both of these in the calculator. So I'm sure if you have problems like this, I'll be wanting you to show the integration process, show work. Make sure you read, the directions. Anyway, this one's basic, right? Nothing weird going on here. Should be easy to integrate. Okay, simple things. Pull the 3 to the side, integrate e squared, that's x cubed over 3. Plus x to the 4th over 4. Remember, after you integrate, the integral sign goes away. This is, those cancel out. This is a binomial. If you want to evaluate it from x equals 1 to x equals 2, you need these parentheses. They'll steal points from you on the AP exam for stuff like this. Don't lose points because of notation, okay? We focus a lot on notation here. I want to make sure you're strong with your notation, so make sure you're focusing on stuff like that. No 0 here, but whatever. Plug in the 2. 2 cubed is 8. Minus 2 to the 4th over 4, so 2 to the 4th is 16, divided by 4 is 4. Minus, let's plug in the 1, 1 cubed, plus what, 1/4? Have some fun. This is really 4 minus 1, minus 1/4. So really 3 minus 1/4. Well, I feel like I did something extremely incorrect here. Oh, I put a minus sign right here instead of a plus sign. That was stupid. So 8 plus 4 over here, so that should really become 12. Sorry about that. Okay, so I think the rest of it is right? I have the plus sign over here. So easy to make silly mistakes like that. I did that on purpose to see if anybody was actually going to notice. So 12 minus 1, what is this now? 11 minus 1/4. Hey, not for nothing, 11 minus 1/4. You could just say 10.75, right? There's nothing wrong with getting decimal. It's just the problem is on multiple choice, they probably won't give you the decimal equivalent. So you have to multiply by 4 top and bottom here. 44. I like numbers of that caliber. Minus 1/4, which is going to equal 43/4. Okay, which is kind of silly instead of writing 10.75. But this is probably what you'd see in multiple choice. Nothing wrong with this. Part 2 problem, you wouldn't even have to simplify. So we'd actually leave it like this on the AP exam. But once again, you can't do that until you're an AP student. You're not an AP student in this class yet. One more, okay? And you can be trying these. You can pause the video at any time, try the problems out. That's what's kind of cool about video instruction. The problem with video instruction is you lose that live interaction in the classroom, which is my favorite part of the job, joking around with you guys, making fun of people, getting made fun of back. And also in video instruction, Students need to be responsible and actually watch the videos every day. And for honor students and aspiring AP students like yourselves, I would think that you would, even though some of you don't. If it was a readings class, we'd really be in trouble. Anyway, here we have the integral from 0 to 1 of 2x over 2x squared plus 1 quantity cubed with respect to x. At this point in time, I'd ask, a volunteer, do you know how to integrate this thing? And it's not basic integration. You can see the division right here. You can even see the base of a numerical exponent is not one single letter. So I go use substitution. Set u equal to 2x squared plus 1. Set u equal to the base of a numerical exponent. That's base of numerical exponent right there. So here we have tres substituciones, right? Let's change those bounds. If x is 0, u is 1. And if x is 1, looks like u is 3. The 2x, he's still there, but not for long, because this becomes du over the derivative of u, which is 4x is equal to dx. So you can see that x is going to cancel out. I'm going to bring the 2x squared plus 1 upstairs, raise them to the negative 3, so u's raised to the negative 3, and then we got our du over 4x. So now we know these x's are going to cancel out. Okay, and you're pulling out a 1/2, right? 2 over 4, pull a 1/2 out to the side. And now you're just integrating u to the negative 3 with respect to u. Add 1 to the exponent, divide by that number, and evaluate it from u equals 1 to u equals 3. Don't tell me negative 3 plus 1 is equal to negative 4. Another classic mistake. I already made a couple of classic mistakes on these videos, which luckily I caught in time so I could use them as teaching tools. So here we get what? Put the negative upstairs with the 1. Downstairs, you got a 4 and a u squared. We'll evaluate that from 1 to 3. A lot of times it makes sense to simplify these things before you plug in. It can make things a lot easier. Plug in the 3 first. So negative 1 over 4 times 3 squared. So negative 1 over 4 times 9. So negative 1 over 36. Check this out. Minus negative 1 over, right? It becomes a plus sign. 1 over 4 times 1 squared. So 1/4. So common denominator of 36 here. Pretty easy, right? Multiply by 9, top and bottom. And it looks like we end up with 8 over 36, which is a fine answer. Divide by 4, top and bottom, and you'd get 2 over 9. Also, pretty nice answer right there. Is it 2 over 9? Am I crazy? It is, right? Okay. Who else are the people who just divide by 2, top and bottom first, right? And get 4 over 18, and that does become 2 over 9. Easier to do it this way, but I get it, okay? That's it for today, okay? Not really a big lesson. Like I said, we don't have much left. Tomorrow's lessons actually be even shorter, but here's your homework problem. Only one. Okay, so copy this thing down. We'll start the next lesson by doing this homework problem. Then we'll do a cool problem that shows up in the AP every now and then. And that'll be it, okay? And that's technically the last chapter. So tomorrow next week we might get into Riemann sums, or I might just split some other stuff up. Not sure exactly what it is I'm going to do. I think we got to get into a little bit of Riemann sums, though, because we have some extra time. Anyway, so hopefully you're looking at this stuff, okay? Get in touch with me if you need to. Have a safe and, a healthy time out there. And it's Mr. Berto signing off until we meet again. When do you watch these videos? Do you get up early in the morning, sit there and do your work? Do you put it all off until 12 o'clock at night, 1 o'clock in the morning? Sometimes you guys submit assignments at 4 a.m. It's pretty funny. I remember what it was like to be a high school student as well. I used to stay up late and, sleep really late until I had kids. It doesn't happen anymore. Now I'm up early, which is why my Google Meets are going to be at either 8:30 or 9 in the morning. Sorry, Charlies. Anyway, so that's it. And try that homework, and we'll see you tomorrow. Adios.